Hey everyone, and welcome. Today we're going to pull back the curtain on the hidden world inside the atom. We're going to figure out the simple set of rules that tells every single electron exactly where it's supposed to go. So where do these tiny electrons actually live? You might picture them just buzzing around the nucleus like a chaotic swarm of bees. But nope, that's not it at all. Their setup is incredibly organized, and it's all governed by a strict set of laws. So think of it less like a random cloud and more like a perfectly organized apartment building.
And just like any good apartment building, there are house rules. Today, we're going to walk through the 3 main rules that every single electron has to follow. Once you get these down, you can basically map out the structure of almost any atom. So let's jump right into rule number 1.
Okay, our first rule is the most fundamental one. It's all about saving energy. In our little apartment building analogy, this is super simple. You fill up the apartments on the ground floor before you start moving anyone into the penthouse suites. Now, the official sciencey name for this is the Aufbau Principle. But all it really says is that electrons are, well, kind of lazy. They will always take the spot or orbital that has the lowest possible energy before they even think about moving to a higher energy one. And this is just a core principle of how the universe works, right? Things always try to find their most stable, lowest energy state. For electrons, that just means filling up the atom from the ground floor up, one level at a time.
And here it is. This is the exact map they follow. Electrons always start at 1s. That's the first floor, the one with the least energy. Once that's full, then they move up to 2s, then to 2p, and so on. Getting this sequence down is the key to pretty much everything.
Okay, let's move on to our second rule. Now that we know which floors to fill first, we need to know the rules for each individual room, or what we call an orbital. And I like to call this one the roommate rule.
This one's called the Pauli Exclusion principle, and it has 2 really simple parts. First, each room can only hold 2 electrons, max, no more, no exceptions. And second, if 2 electrons are sharing a room, they have to have opposite spins. So, what's with this opposite spin thing? Well, it's what makes the 2 electrons in that room unique. Even though they're in the same space, they're not identical. Just think of them as 2 roommates with opposite personalities. That combination keeps everything stable and balanced. We actually showed this with these simple up and down arrows. One electron is called spin up, and its roommate is spin down. This little notation is just how we represent 2 electrons living together peacefully in the same orbital, following the rules.
All right, on to our third and final house rule. This one really comes into play when you get to a floor that has multiple rooms at the exact same energy level, like the p orbitals, which always come in a set of 3. Let's call this one the empty room rule.
Officially, it's called Hund's rule. And really, it all comes down to personal space. The rule says that if there are empty rooms available on the same floor, electrons will each take their own private room before they even consider pairing up with a roommate. It's just more stable that way.
Let's say 3 electrons show up to a floor that has 3 empty rooms, all at the same energy. They don't all cram into one room. Nope, 1 electron goes into each empty room, and they all have the same spin. They just spread out and claim their own space first.
So what happens if a 4th electron comes along? Well, now that all the rooms have 1 occupant, it doesn't have a choice. It has to pair up. So it'll pop into one of the already occupied rooms, but it'll take on the opposite spin, just like the roommate rule says it has to. And this whole oxygen has a total of 8 electrons we need to find homes for. Let's start with the first 2. Rule number 1 says they have to go in the lowest energy spot, which is 1s. Then rule number 2 says 2 can fit in there, as long as they have opposite spins. So we write that as 1s squared. And just like that, 2 electrons are placed. What about electrons 3 and 4? Well, the 1s orbital is full now, so according to rule 1, we have to move up to the next lowest energy level, and that's 2s. Rule 2 applies again, so 2 electrons with opposite spins can pair up there. Our address is now 1s squared, 2s squared. We're halfway there.
We've got 4 electrons left to place. The next level up is 2p, which has those 3 rooms. And this is where rule number 3, Hund's rule, is absolutely essential. The first 3 of our remaining electrons go one by one into each of the 3 empty p orbitals. Then, our very last 8th electron has no choice but to pair up in that first p orbital.
And there you have it, the final result. This table shows the complete address for all 8 of oxygen's electrons. You can see the 1s and 2s orbitals are full, and in the 2p orbitals, you can literally see Hund's rule in action, with 2 of those electrons having their own private room. So, the big thing to remember here is that these aren't just 3 random rules. They're a system that works together. The Aufbau Principle sets the order, the Pauli Principle sets the limit for each room, and Hund's rule manages how everyone moves in. Together, they create the most stable, most efficient arrangement for the atom. So let's do a super quick recap of our 3 house rules. 1. Fill the lowest floors first. 2. Maximum 2 roommates per room, and they can't be identical. And 3. Everybody gets their own room before anyone has to share. That's it. Now, these 3 rules perfectly describe how electrons are set up in a stable, calm, low-energy atom. But this brings up a really cool question. What happens when an atom absorbs a bunch of energy and an electron gets so excited that it actually jumps to a higher floor, breaking the rules, even for a moment? Well, that's a story for another day.